Good morning, one and all. I am Dr. Ramya Swetha, Assistant Professor, Department of Civil Engineering from Institute of Aeronautical Engineering. Today, our topic is we are continuing the modification by inclusion and confinement. In previous class, what we understand, what is the soil reinforcement with geotextiles and also the ground anchors. These are the two different practical problems and how we are going to solve those, what are the various steps involved in that for getting the expected outcome. Now in this class we are understanding the various different kinds of practical issues, scenarios in this particular class. So in this soil reinforcement with geogrids. So what is the scenario in this is a retaining wall requires soil reinforcement to prevent failure due to lateral earth pressure. So it means this is the expected outcome. We are getting the without lateral earth, failures without lateral, there is no kind of to prevent the failure due to the lateral earth pressure. So that is the thing. So for this already they choose, we know the technique which we are going to follow, that is equal to soil reinforcement with geogrids. So in a retaining wall requires soil reinforcement, that soil has what are the properties are also mentioned in this particular scenario. In this, the soil is cohesion, angle of internal friction is given, what is the unit weight of the soil, where the retaining wall heights, these are all the required parameters are mentioned in this particular problem. So in this problem statement, we know the soil cohesion, that is 10 kPa, angle of friction is 30 degrees, unit weight is 18 kilonewton per meter cube, and the wall height is 6 meters height. So this is the things, and geogrid layers will placed at 1 meter vertical intervals. So where the geogrids are also placed is mentioned. So we know the all the scenario. Now what is the procedure? What is the solution for this? The first step what we have to do is calculate the lateral earth pressure, and after that determine the lateral earth pressure at the base of the wall and check the tensile strength required for the geogrid and select a geogrid that can be provide this tensile strength. These are the various steps which we are going to involve in this particular problem. So in this, the first thing is calculate the lateral earth pressure. In this, using Rankine's theory for effective earth pressure. So in this, we are using this Rankine's theory for effective earth pressure. Using that formula, we know this is equal to 30 degrees. So now tan square is equal to 14 degrees minus 15. Finally, that is equal to 1 by 3. So this active earth pressure is equal to 1 by 3. Determine the lateral earth pressure at base of the wall, that is equal to sigma h, where the base, that is equal to active earth pressure, and those gamma and h, this unit weight of the soil and height of the retaining wall, that is nothing but the 36 kPa. And now check the tensile strength required for the geogrid. So each geogrid layer supports a portion of lateral earth pressure, assuming uniform distribution. Here we are assuming the uniform distribution, that UDL, uniform distribution. Now tensile force per each layer. So that is equal to overall base is there. So here also the number of layers is equal to 6. So now tensile force per each layer is equal to that overall what we get, that is equal to tensile force. So sigma h base by number of layers, that is equal to 36 by 6. So that is the tensile force per each layer. Now we are selecting. So now we are selecting the geogrid that can provide this tensile strength. So this is the one. Next move on, just simply what we understand, we are doing some calculation for getting the Tensile strength, we are checking whether it is tensile force per each layer is understandable or not. Based on that, we are going to understand the things. Now, here, so this is equal to 6. Now, ground anchors in slope distribution, slope stabilization. In slope stabilization, in the scenario, a slope requires stabilization using ground anchors. The slope height is 10 meters and the slope angle is 30 degrees. What are some of the properties we know for this soil? Those are, soil is cohesive soil, that cohesion is equal to 12 kPa, angle of friction 25 degrees, unit weight of the soil is equal to 19 kilonewton per meter square. Anchors are to be placed at spacing of 2 meters horizontal and 3 meters vertical. This is the scenario we have. For this, we are doing the calculate the factor of safety without anchors, determine the required additional force from the anchors to achieve factor of safety of 1.5, and also design the ground anchors. These are the calculations which we are going to understand in this particular scenario. So in this scenario is ground anchors in slope stabilization. In this, calculate the factor of safety with anchors. So using the formula, we are finding the factor of safety, that is equal to what we get after doing all the calculation, that is equal to 0.8. So determine the required additional force from anchors to achieve factor of safety 1.5. So the required is 1.5. So the required stabilizing factor of force is equal to, using this formula, the required stabilization force is equal to, so here we are going to do the processes in reverse. So the factor of safety, the required is the 1.5. Now what is the required stabilization force? So of doing all the calculation, we will get that is equal to 57.75 kilonewton. So now design the anchors. Assume each anchor can resist 30 kilonewton. So number of anchors is equal to, what is the required stabilization slope divided by 30, that gives the 2. Each anchor can resist how much? So something it will get, it is nearly equal to 2. So therefore 2 anchors are going to place in a row to stabilize the slope. For stabilize the slope, how many anchors are required? For knowing about the factor of safety, based on the factor of safety, first we calculate the factor of safety without anchors and determine what is the required stabilization force, and each anchor can resist how much is depends upon the how many number of anchors are going to placed. In this, rock bolting in tunnel support. So in this scenario, a tunnel is being constructed through a rock with following properties. In this, unconfined compressive strength 60 MPa, unit weight of rock 25 kilonewton per meter cube, tunnel diameter 5 meters. Rock bolts are to be installed in a pattern of 1.5 meters spacing. This is the scenario which we have. So using this rock bolting in tunnel support, what is the process involved in this? So in this, first we are going to calculate the support pressure required. What is the pressure required? And determine the load on the each rock bolt. How much load is he going to consider on each rock bolt? Select rock bolts with appropriate capacity. These are the things which we are going to understand in this particular problem, that is rock bolting in tunneling. This is the scenario. What is the unconfined compressive strength, unit weight, tunnel diameter, and how much spacing are the known things. Now the solution. In the first step, calculate the support pressure required. So in this, using this formula, assuming a coefficient of rock pressure, that is K is equal to 0.5, find out the support pressure, how much it is required. So that is equal to, after the calculation, we will get 62.5 kilonewton per meter square. After that, determine the load on each rock bolt. Now, each bolt supports an area, that is equal to A is equal to spacing area, that is equal to spacing square, that is equal to 1.5 into 1.5 means 2.25 meter square. Load per unit, load per bolt, each bolt, that is equal to load into area, that is equal to 62.5 into 2.25, 140.625 kilonewtons. So 140.625 kilonewtons for load on the each bolt of the rock bolt. Each rock bolt, it is going to bear that much load. Now select the rock bolts with appropriate capacity. So choose rock bolts with a capacity exceeding of this 140.625 kilonewton, considering a factor of safety factor. Like this, we are understanding this rock bolting in tunneling support scenario. And one more is soil nailing for excavation support. In this scenario, we are doing the soil nailing for excavation support. So for excavation support is the required thing. So we are using the soil nailing technique. So what is the process involved in this? So an excavation requires support using soil nails. The excavation depth is 8 meters and the soil has cohesion, that is 15 kPa, and angle of internal friction 28 degrees. Unit weight is 17 kilonewton per meter cube. These soil nails are placed at 2 meters vertical and horizontal spacing. 2 meters vertical and horizontal spacing. This is the scenario we have for the technique soil nailing. So the required thing is support the excavation support. So in this, we are going to calculate the active earth pressure, determine the load on the each nail. These are the things which we are going to understand in this particular scenario, that is soil nailing. So in this, the first thing is calculate the active earth pressure. So using the formula, we are going to calculate the active earth pressure and the base. So those are nothing but we will get, that is equal to 40.8 kilopascals. So now determine the load on each nail, that is equal to area is equal to 2 into 2. Spacing square, that is equal to 4 meter square. Now load per each nail is equal to sigma is base multiplied by area, that is equal to 40.8 into multiplied by 4, that is equal to 163.2 kilonewton. So check the tensile strength and pull out resistance of nails. So now select the nails with tensile strength and pull out resistance greater than this 163.2 kilonewton, considering a factor of safety. So for each kind of soil nailing have their own kind of calculations, and rock bolting has their own kind of, and here also where we are doing. So this soil reinforcement with geogrids. Here ground anchors are used for the slope stabilization, and rock bolting is used for tunnel support. It may another kind, means the expected outcome is different, that may affect the process also in some of the cases. Soil nailing for excavation support. Now design of strip reinforcement in soft clay. So whenever the soft clay is there, we are choose this strip reinforcement for getting the desired properties. So in this scenario, a highway embankment requires reinforcement using strip reinforcement. The embankment height is 5 meters and soft clay soil has the following properties. Those are cohesion, that is 25 kilopascals, angle of internal friction, that is purely cohesion, that it means 0 degrees. Unit weight is 16 kilonewtons per meters cube. This strip reinforcement are placed at 1 meter vertical spacing. So it is for the 1 meter vertical spacing. Now in this, the calculate the first part is the lateral earth pressure. Find out the lateral earth pressure. Determine the force per unit length with the strip reinforcement. Select appropriate strip reinforcement. These are the steps which are going to involve in this scenario. So using the undrained condition of the cohesion soil, so it gives the lateral earth pressure, that is equal to 16 multiplied by 5, that is equal to 80 kilopascals, that is equal to 16 into 5 meters. And now determine the force per unit length of the strip reinforcement. So in this, so F is equal to sigma h into spacing. That spacing is equal to 1 meter. It means 80 kilonewton per meter. Now choose a strip reinforcement that can provide a tensile capacity at least 80 kilonewton per meter or higher than that we are going to consider as a safety factor. In this, we may understand jet grouting for foundation improvement also. So this is one more problem we are going to understand. A high-rise building is planned on loose and sandy soil. These are the conditions. So loose and sandy soils, we are going to construct high-rise building. This is the project requirement. And this is the available soil conditions. So how we are going, which type of technique helps to get the project requirement of the soil condition? These available soil condition which use to technique as get the desired properties for to get choose the technique to get the desired properties of the soil for project requirements. So in this we are going to increase the soil's load bearing capacity because it's a high rise building. So the expected outcomes is load bearing capacity. Here they mention the technique also. So here we choose this technique, that is jet grouting. So now in this solution, site investigation, as per site investigation, soil type is loose sand. Depth of weak of the soil layer is 5 meters. Target compressive strength after grouting is 2 MPa. Now, what are the design procedures which we are going to involve in this? First, jet grouting columns. After that, the jet grouting process we are going to start, that is drilling, grout injection, formation of columns. After that, we are do the calculations. Now, in this design, jet grouting columns, determine diameter 1 meter, spacing of columns 2 meters in triangular pattern to ensure uniform load distribution and overlap of improved zones. In grout mix, 1 part cement to 5 parts water. Jet grouting process step, that is drilling. Drill holes to the required depth 5 meters where the jet grouting columns are to be installed. Now grout injection in this high pressure jetting and grout mix. So in high pressure jetting, use high pressure jets, typically 300 to 600 bar, to inject the grout into the soil. The jet grouting process create a soil cement column by mixing the grout with on-site soil. Ground mix, the typical ground mix for jet grouting is 1 part cement to 5 parts water. For 1 cubic meter of grout, you need approximately 333 kg of cement and 167 liters of water. Formation of columns, create columns with diameter of 1 meter. The columns should be spaced 2 meters apart in a triangular grid pattern to ensure that the improved zones overlap and perform uniform support. In this, those calculations, load bearing capacity improvement for these, volume of a single column, number of columns per square meter, total volume of grout per square meter, grout material requirements are the things which we are going to understand. The first thing, we are going to calculate volume of single column. We'll get some answer. So number of columns per square meter, we are doing that calculation as per triangular pattern with 2 meter spacing. The number of columns per square meter can be approximated as. So like that, the approximate one is the answer for columns per square meter. Total volume of the grout per square meter. Now ground material requirement for 2.27 cubic meter grout, the required amount of cement we are going to calculate. And now expected improvement in load bearing capacity, we are going to testing what are the things and also monitoring the parameters in this jet grouting. In this expected improvement in the load bearing capacity, The target compressive strength after grouting is 2 MPa. The improvement in load bearing capacity is a function to strengthen the grouted column and their spacing. So in this unconfined compressive test, perform tests on samples extracted from the grouted columns to ensure they meet the target strength of 2 MPa. This strength is indicative of the ability of the grouted soil to bear the load of the high-rise building. So for high-rise building, it is going to bear that load. In this, the settlement plates and piezometers are going to be monitoring. So install settlement plates at various locations to monitor vertical displacements of the foundation. Regularly measure and record the settlements to ensure that they are within the acceptable limits. In piezometer, install piezometers to monitor pore water pressure into the soil. Elevated pore water pressures can indicate potential issues with soil stability, especially after heavy rainfalls. So these are the expected outcomes what we get for these jet grouting for the high-rise building to get the desired soil properties. That is increased load bearing capacity, stability and safety. So the grouted soil column significantly improves the load bearing capacity of the foundation. The improved foundation is capable of supporting the high-rise building without excessive settlement. So in this, the high compressive strength of grouted columns E 2 MPa ensures that the foundation remains stable under the imposed loads. In regular monitoring, ensuring that any potential issues are detected and addressed promptly. So in overall summary, the jet grouting provides a solution for improving the load bearing capacity of the loose sandy soils by creating soil cement columns with high compressive strength. The foundation becomes capable of supporting heavy structure such as high-rise building. So the detailed process involves its site investigation, careful design, precise grout injection and rigorous testing and monitoring to ensure the long-term stability and the performance. These are the some of the different scenarios which we are going to understand in this soil modification under the modification by inclusion and the confinement. So, a few more we will see in our next class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.